Hello, my dear friends. I'm Shubham from LearnHub, the free learning platform where you can study physics, chemistry, maths, biology absolutely for free at learnohub.com. So then, let's start. So friends, we are going to start with the new chapter in this video, chapter number 2, chemical bonding. Yes, we have completed your first chapter, and in this video we are going to study all the concepts of ionic bonding. After that, we are going to solve some questions. So without wasting much time, let's start and let's rock. So friends, before starting to learn this chapter, the first and the foremost question which should arise in your mind and in the mind of every student before learning any chapter, that why we should study that particular chapter, right? So why study chemical bonding? Now, you would be seeing on the screen there is salt, right? You would have guessed it right. And this salt, the table salt, NaCl, we use it every day, okay? Our mommy uses it for cooking food, and without this salt, our food would taste like hell, right? It won't taste good, absolutely. Now, let me tell you an interesting thing about this salt. If you want to boil this salt, or if you want to first melt this salt, okay, so you have to heat it to 800 degrees centigrade. So this means that its melting point is 800 degrees centigrade. And if you want to boil the salt, you have to heat it till 1400, roughly around 1400 degrees centigrade. Now, its boiling and melting points are so high, right? Now, why on this earth a simple chemical compound like salt has so high boiling and melting points, right? Do you want to know the answer? So for that, you need to study chemical bonding, and like this, we would see the answers of so many interesting questions. So I am definitely sure that you are feeling convinced and excited. So then let's start. So friends, I know that you have studied chemical bonding in your previous grade, 9th grade as well, right? And in 9th grade, you have studied the basics of chemical bonding and the basics of ionic bonding and covalent bonding, along with the orbit structure diagrams of ionic compounds and orbit structure diagrams of some covalent compounds and covalent molecules, right? Now, what we are going to do, we are going to just quickly revise the concepts which you have learned in your 9th grade, okay? The basics of ionic bonding and the basics of covalent bonding, and then we are going to get into the crux of this chapter, which is the electron dot structures of ionic compounds, and then we are going to study the properties of ionic compounds, okay, in case of ionic bonding. And when we are going to study the covalent bonding, we are going to again go through the basics of covalent bonding, okay? We are going to revise it, and then we are going to see the crux of covalent bonding, which is the electron dot structures of covalent compounds and covalent molecules, and the properties of covalent compounds, okay? And lastly, you would be introduced to the third type of chemical bond, which you haven't studied in your previous grade, which is coordinate bond, okay? Very interesting type of bond, and just the basics and some compounds we are going to study, the formation of some compounds in case of coordinate bonding as well, okay? So now let's start with chemical bond itself, okay? Let's start revising the basic concepts. So I definitely know you all know the chemical bond, but let's just brush up the basics. So chemical bond is actually a force of attraction, right? A force of attraction or attractive force between the constituent particles, okay? And this constituent particles can be atoms or it can be ions, okay? And this attractive force, okay, it is holding the constituent particles, right, together. It is holding the constituent particle together in a chemical species, okay? So if the constituent particles are atoms, so the chemical species would be molecule, okay? If the constituent particles are ions, okay, which are being held by this attractive force, okay, then the chemical species would be the ionic compound, okay? So this attractive force which is holding the atoms or ions, okay, together in a molecule or ionic compound is called the chemical bond, okay? Very simple. Now, I have already introduced you to the three types of chemical bonds. Now let's first start with ionic bond, the basics of ionic bond. So let's quickly revise ionic bond and ionic compound. So ionic bond is actually a chemical bond which is formed due to the transfer of electron or electrons, okay, from, now this is the important thing, from the atom of an element, okay, so I'm taking suppose sodium, so the bond which is formed due to the transfer of electron, okay, so this is the outermost shell of the sodium atom, so transfer of electron from the atom of an element, so this is atom of sodium element, and here the electron is getting transferred to the atom of another element, okay, so here comes our villain, okay, this is the hero, this is the villain, and this is accepting the electron, the chlorine atom is accepting the electron, and the bond which is formed due to the transfer of electron from the atom of an element to another, to the atom of another element, okay, is called as ionic or electrovalent bond. Very simple. And what is ionic or electrovalent compound? We already know. The compound which is formed due to the transfer of electrons, right, from the atom of an element, same thing. The compound which is formed due to the transfer of electron from the atom of an element to the atom of another element, okay, so that compound is called as electrovalent compound or electrovalent or ionic compound. Next is electrovalency. Okay, so what is the electrovalency of an atom of an element? Okay, so it's simply the number of electrons that particular atom of an element loses or gains to form ionic bond. Okay, that's it. So let's apply this concept quickly. I'm taking an example of ionic compound NaCl, we all know. Okay, so what is the electrovalency of sodium here in this case, and what is the electrovalency of chlorine here in this case? Very simple. We all know that sodium loses one electron. Okay, so yes, we just now saw the number of electrons an atom of an element loses or gains. So it is losing one electron to form the ionic bond, right? So this means the electrovalency of sodium is 1. Similarly, chlorine is accepting that particular electron, so it is gaining the one electron to form the ionic bond. So this means that chlorine has electrovalency 1. Now try to calculate the electrovalency of MgCl2 on your own. Okay, don't make it wrong. Okay, you can pause the video right here and then you can check the answer. Okay, so Mg here, it donates 2 electrons, right, or loses 2 electrons to form the ionic bond, so its electrovalency would be 2, but these 2 electrons are accepted, okay, by 2 chlorine atoms, right? So what we can say about the chlorine here, chlorine would have the electrovalency 1 because the atom of chlorine accepts only 1 electron to form the ionic bond, right, so that's why its electrovalency would be 1, it would not be 2. Okay, so interesting. Now let's see the conditions for the formation of ionic bond. Okay, so very simple conditions are there. Okay, 3 conditions, and we can just remember them with the help of the concept of ionic bond itself. So we know what happens when the ionic bond is formed. One of the atoms loses the electron and another atom, okay, gains that very much electron. Okay, it may lose 1 or more electrons and the other atom gains 1 or more electrons. Okay, so it depends on the compound which is getting formed, but the major concern is, the main concept is, one atom loses the electron, another atom gains up the electron, so there is an electron transfer, right, and after this electron transfer ionic bond is formed. Now this means that one atom should definitely have the tendency to easily lose the electron, right? This atom should have tendency to easily lose the electron. Now how we can express this tendency? Okay, in terms of ionization energy. So if this atom has tendency to easily lose the electron, this means that we can say that it is having less ionization energy. Why? Because this means that less energy is required to remove the electron. So if less energy is required to remove the electron, it easily loses the electron, correct? So one of the atoms should have low ionization energy. Very simple. Now same way the other atom should easily gain the electron. That should be our major concern. So if the other atom should easily gain the electron, so this means that how we can express this ability in terms of electron affinity? So it should have high electron affinity. That's when it would easily gain the electron. Okay, the affinity for the electron should be very high. So other atom should have high electron affinity, then only it would easily gain the electron. And the third condition is the atoms of different elements. We know ionic compounds are formed between the atoms of different elements, right? Now, between the atoms of the different elements, the electronegativity difference should be large. Okay. Now, we would learn the reason of this concept in your higher standard, but for now, you just remember one thing, you just understand this concept by one thing, that when the electronegativity difference is very large, the electron transfer becomes easier. Okay. And what else we want to form an ionic bond? We just want that electron transfer should be very much easy. So ionic bond would be easily formed. So these are the three conditions. Okay. Now based on these three conditions, we can clearly make out that, see, the ionic bond would form between metal and a non-metal, right? How I'm saying this thing? Just try to match the conditions. See, the atom of the metal would have low ionization energy. Yes, because metals have low ionization energy. We have studied in the first chapter. Similarly, the atom of the non-metal would have high electron affinity. Correct? We have also studied this in the first chapter. And the third condition, the atoms of different elements should have large electronegativity difference. So we all know that metals have very low electronegativity, while non-metals have very high electronegativity, right? That's why we call them as electronegative elements, and we call metals as electropositive, the opposite of electronegative, right? So this means that if they are having low electronegativity, if non-metals are having high electronegativity, then the electronegativity difference between metal and non-metal would be definitely very high, would be definitely very large, and that's the reason ionic bonds are formed between metals and non-metals. Okay, so this can be the question which this question could be asked in your exams. Very simply, ionic bond can be formed between metals and non-metals. Okay, so dash and dash, it would be a fill in the blanks, or it can be anything. Okay, a one-liner answer as well. So friends, till this point we have revised all the basics of ionic bonding. Okay, now let's move on to the main crux of this chapter, which is the electron dot structures of ionic compounds. Okay, we are going to see the electron dot structures of NaCl, MgCl2 and calcium oxide. But before that, let's first see how to draw an electron dot structure. Okay, the basics of electron dot structure, you have to just remember the three simple rules to draw the electron dot structures, and then you can draw the electron dot structures of any compound. Okay, so let's start first learning how to draw an electron dot structure. So if I have to draw the electron dot structure of an atom, okay, so the first rule says that you have to first write the symbol of the element, okay, of that particular atom. So I have to draw the electron dot structure of oxygen atom, then I would just first write the symbol of oxygen. Okay, then I will represent, okay, then the rule is saying that you have to represent the outermost shell electrons, okay, with the help of dots. So there comes the name electron dot structure. Okay, so the outermost shell electrons of oxygen I have to represent with the help of dots. So I know oxygen's outermost shell has 6 electrons. From its electronic configuration we can get this thing. Now before representing the outermost shell electrons with the help of dots, let's move on to the second rule, because it tells us how to represent. Okay, the second rule says that paired electrons should be represented by pair of dots, unpaired electrons should be represented by single dot. Okay, so what we would do, we would first pair up the electrons. So 1, 2, 3, 4, 5, 6. So I have paired up these 6 electrons. I have 3 pairs. Now how I would represent this? Very simple. We have to not create the mess of electrons, okay, around the symbol. So that what I would do, I would just represent one pair on the one side, second pair on the other side, third pair on the third side. Don't do in this way. Okay, here only you are just representing the pairs on the same side, or like side by side to each other. Okay, represent it on different sides, so it would be neat and clean. Okay, and it would be easy to understand as well. Now how I would represent the unpaired electron then? With the help of single dot. So let's take an example of fluorine here. Okay, so fluorine has electronic configuration 2,7. So I would again pair up the electrons. So 6 electrons would be paired in this way. I have 3 pairs, and the last electron, 7th electron, would be unpaired. So in the same way, just like oxygen, I would arrange these 6 electrons in the 3 pairs on 3 sides, and the last unpaired electron with the help of single dot on the last side. Okay, so in this way you have to represent the outermost shell electrons in case of atoms. Now third rule is used, or third rule would be helpful for us when we are drawing the electron dot structures of molecules. So suppose I am having these two molecules, HCl and Cl2. Okay, now the rule states us that it's very simple. When we are representing the outermost shell electrons, okay, of the atoms, okay, of a particular molecule. So if the atoms, so the rule is saying that you have to use different symbols for the different atoms, okay, in the molecule. So I would use, if I am using dot for hydrogen, then the rule says that use either circles or cross for the other atom, for representing the outermost shell electrons of the other atom. So then I have to use cross. Okay, same way, if I am using dot for this chlorine atom, I have to use cross or circle for the other chlorine atom. Okay, but when we are drawing the electron dot structures, in case of a molecule, okay, which is made up of the atoms of same element, okay, here in this case is chlorine. So you can either, what you can do is you can represent the outermost shell electrons with the same symbol as well. Okay, so what I suggest to you is, in case of a molecule, in case of a molecule which is made up of atoms of same element, use same symbol. Okay, very simple. And in case of a molecule which is made up of atoms of different elements, use different symbol. Now this you should keep in your mind, you should never forget this. Okay, so for that, let's make it simple. So I told you to use the same symbol for the molecule having atoms of same element. So you would automatically remember that, oh, I have to use different symbols for the molecules having the atoms of different elements. Okay, so now let's see the electron dot structure of NaCl. Now I know in the previous grade you have studied the orbit structures of NaCl, MgCl2 and calcium oxide. So I pretty know you have a basic idea how these compounds are formed. But in order to draw the electron dot structure as well, we have to first understand how these compounds are formed. Okay, so we will quickly go through the process how NaCl is formed, and then you would be able to draw the electron dot structure of NaCl very easily. So we know it is made up of sodium and chlorine atoms. Now the same logic, sodium has 1 electron in its outermost shell. Okay, from its electronic configuration we can find out, and chlorine has 7 electrons in its outermost shell. Okay, now sodium wants to get rid of its 1 electron anyhow, so that it would attain the configuration of neon, electronic configuration of neon, which is the nearest noble gas to sodium. Okay, it is having configuration 2,8. So after getting rid of this 1 electron, it would have the electronic configuration 2,8. So what it does, it just loses that 1 electron and forms Na plus, which is having the electronic configuration 2,8, same as that of the neon, the nearest noble gas. Okay, same way, now what chlorine does, chlorine just takes the chance. Chlorine atom, what it does, it just picks up this electron which is lost by sodium. Okay, now it's a very good chance for the chlorine. Once it picks up this electron, its outermost shell gets filled, 8 electrons, and it attains the electronic configuration of the nearest noble gas to chlorine, which is argon. Okay, 2,8,8. Now it accepts the electron, but it forms Cl minus in this case. Okay, now this Cl minus and Na plus, now these are charges. This is a positive charge, negative charge. So we know like charges repel each other, unlike charges attract each other. So in this way they find an affection for each other. Okay, so they just attract each other, and there develops a strong electrostatic force of attraction between them. Okay, now you have to remember this word because it is a key word, electrostatic force of attraction. Okay, develops between the Na plus and Cl minus, and this results into the formation of ionic bond. Okay, and the compound NaCl ionic compound is formed. So this very story you have to just represent with the help of electron dot structure. As simple as that. Okay, so I'm having this Na. So what we have learned, first we have to represent the electron dot structures of individual atoms. Okay, Na and Cl. Then how they are combining we have to show, and then we have to show the compound NaCl. So first Na, I have written the symbol. Then the outermost shell electrons, I would represent it with the help of dots, right? Or circles or crosses. Any one symbol you pick. So I like dot first. So I have represented the outermost shell electron of sodium, which is 1, with the help of 1 dot. Then comes chlorine in the picture. So chlorine has 7 electrons. So what I would use now I cannot use the dot, right? You remember I have told you, when you are using the representation, the symbols for representing the electrons, if the atoms are of different elements, use different symbols. If the atoms are of same element, use same symbols. So these are the atoms of different elements, use different symbols. Simple. So I would represent 7 electrons in this way: 1, 2, 3, 4, 5, 6 and 7. Okay, 7 crosses. Now what happens? We know this sodium atom is losing this electron, chlorine is picking up this electron, and what is getting formed? NaCl. So how NaCl is formed? After losing this electron, Na becomes Na plus. So we would just write Na plus here. Okay, no electron now to show here in the compound, and chlorine picks up this electron. So chlorine will have its own 7 electrons this way, and the electron of sodium would come here. Okay, so now 8 electrons are there in the outermost shell of chlorine. It's very much happy, but being happy, it is also getting a negative charge. Don't forget to show the charges, okay, in the ionic compound which is formed when you are drawing the electron dot structure. So simple, that's it. Na plus Cl minus, and this is your electron dot structure for NaCl. So in examinations, they directly give you the atomic numbers and they ask you to draw the electron dot structures. So simply you have to draw this structure by remembering how NaCl is formed, so that you won't make any mistakes. Okay, this arrows, these charges are the small things which you would forget while drawing the structures, and you would miss the marks. Next is MgCl2, magnesium chloride. So same way how sodium chloride is formed, magnesium chloride also has the same type of story. Okay, but there is a slight twist, very slight twist. So first, electronic configuration 2, 8, 2, it has 2 electrons in the outermost shell. Okay, this magnesium wants to get rid of these 2 electrons so that it would have the electronic configuration of neon and it would become stable. Okay, this is the nearest noble gas to magnesium. So it gets rid of its 2 electrons and it forms Mg2 plus, which is having electronic configuration of neon. Very well, clear. Now same story for chlorine 2, 8, 7. Right, 7 electrons. It is in just need of 1 electron so that it would complete its octet, become stable and attain the electronic configuration of argon. Okay, but what is happening here? See, magnesium is giving up 2 electrons. Okay, and our poor chlorine can only accept 1 electron. It cannot accept more than 1 electron anyhow. So what it does, it tells another chlorine atom, he calls his another brother, you say in this way, please come, please help me in gaining the electrons given by magnesium. So what you do is, I will gain 1 electron, you gain another electron. So in this way, both of them would use these 2 electrons. So this electron is gained by this chlorine, suppose, and this electron is gained by this chlorine atom. So what would happen? After gaining the electron, it would become Cl minus. Here also it would become Cl minus. So we are having 2 Cl minus ions and 1 Mg2 plus ion. So see the charges 2 plus and the total charge is minus minus. So minus 1, it's minus 2. So 2 minus, right? So it's getting balanced. So in this way, the 2 electrons which are lost by magnesium are gained by 2 chlorine atoms and 2 chloride ions are formed. So there would be a strong electrostatic force of attraction between this Mg2 plus and this 2 Cl minus ions. Okay, and it would result into the formation of ionic bond and the ionic compound MgCl2. Okay, since there are 2 chlorine atoms, so Cl2. Very clear. Now we have to just show this process with the help of electron dot structure. So what I would do is, I would first write Mg, then it's 2 electrons, so I would represent it with the help of dots. Okay, what would happen? I am having chlorine atoms, but I am having 2 chlorine atoms, right? So same way, 7 electrons, 7 electrons. Okay, now we know this thing. We have drawn the structure of NaCl. 7 electrons of both the chlorine atoms. Now this electron here, it goes to this chlorine atom, as we have seen in the story, and this electron is going to this chlorine atom. Okay, so here it is very important to show 2 arrows. Okay, because 2 electrons are going to different, because each electron is going to the different chlorine atom. And what happens? Mg2 plus is formed, right? And this 2 chlorine atoms, by gaining electron, okay, this is gaining this 1 electron, this chlorine atom is gaining this 1 electron. So what I would do is, I would show just a single chlorine atom, okay, and I would just write 2 in front of it. So this would represent the 2 chloride ions. Okay, here Cl minus ion is formed, right? It's just the same like NaCl. So here the Cl minus ion, not one, there are 2 Cl minus ions, like, right, in this way. This is one Cl minus ion, and after accepting the electron, this is the another Cl minus ion. So what I have done is, I have represented this both of the Cl minus ions by writing just 2 in front of them and showing the chloride minus ion. Okay, so this becomes our MgCl2, and this is the electron dot structure of MgCl2. No need to draw this chloride ion separately. I have just drawn it to show you. In exam, you have to draw this structure. Okay, just don't forget to show the arrows and the charges, and you won't forget if you would remember the process. So that's why I'm telling you to just remember the process, and then you would easily draw the electron dot structure. Okay, now moving ahead to calcium oxide. Now what I would suggest to you is, you pause the video here and you try on your own to write the electron dot structure of calcium oxide. Okay, it's very simple. And once you have written, just resume it, so that to check the answer. Okay, whether you have drawn the right electron dot structure or not. Okay, so let's start. So calcium, same way, 2, 8, 8, 2. Okay, so it is having 2 electrons in its outermost shell. So it just want to get rid of that 2 electrons. So it would attain 2, 8, 8 electronic configuration of argon. So it just get rid of that 2 electron, and it becomes Ca2 plus. Okay, stable. Now these 2 electrons which are lost, who is in front of calcium? Oxygen, right, in calcium oxide. Now oxygen has 2, 6 electronic configuration, so it is in very much need of just 2 electrons, and here calcium gives that 2 electrons, so it would happily gain these 2 electrons. So it is doing the same thing, it is gaining these 2 electrons, and its electronic configuration would become 2, 8, same as that of the neon, so it would be happy now, stable. But after gaining this 2 electron, it is developing 2 minus negative charge. Okay, now this Ca2 plus and O2 minus, see the charges are getting balanced, 2 plus, 2 minus. Now there would be a strong electrostatic force of attraction between them, ionic bond would be formed, and ionic compound calcium oxide is formed, right? Now we have to just represent it with the help of electron dot structure. Very simple. Calcium, okay, 2 electrons in its outermost shell, so I would just draw here 2 dots. Then oxygen, okay, so here oxygen is having 6 electrons in its outermost shell. So 1, 2, 3, 4, 5, 6 different symbols. Okay, do not forget. Now these 2 electrons are going here in this way. So show it with the help of 2 arrows. Either show 2 arrows, or you can show just 1 arrow as well, but then write on that arrow 2 electrons. Okay, very important. So because of the small things, you would lose the marks. Now these 2 arrows are showing these 2 electrons are being accepted by oxygen. What is happening next? Calcium would become Ca2 plus after losing 2 electrons, right? Oxygen, it would become 2 minus, okay, O2 minus ion, oxide ion. So these 2 electrons are here. Okay, now I would just put it in the bracket, and in this way. So Ca2 plus and O2 minus. So I have to just draw this structure, and this is the electron dot structure of calcium oxide. Okay, so moving ahead, the next topic is properties of ionic compounds. We have completed the electron dot structures of all the three ionic compounds, NaCl, MgCl2 and calcium oxide. Now first property is constituent particles. So ionic compounds are made up of which constituent particles? Very clear, we know it very well. Na plus Cl minus, Mg2 plus Cl minus, calcium oxide Ca2 plus and O2 minus. What are these? These are ions, right? So yes, their constituent particles are ions. Now state of existence. So how they exist? So ionic compounds exist in solid state, and these are hard solids. Okay, now let's know the reason of this, why they are in solid state and why they are hard enough. So we know that when the ionic compounds are formed, what is happening? The strong electrostatic force of attraction is being developed between the ions, right? Strong electrostatic force of attraction. And that's when I told you, you have to remember this. This is a key word. Okay. Here, if you would miss electrostatic or force or attraction, any of the word, then it would not sound the same thing. It would not mean the same thing. So the strong electrostatic force of attraction is developing between the ions. And because of this very much strong electrostatic force of attraction, what is happening? The ions are held very much closely to each other. Okay, very much closely and very much strongly. Okay, so now we know that when the constituent particles are held very close to each other and very strongly to each other, so in which state that particular compound would exist, or that particular chemical compound would exist in? Yes, right, solid, because we know solids are like closely packed, right, in this way, like this. And they are hard enough because the force of attraction between the ions is very strong, so we cannot like break them easily. Okay, very clear. Next property is boiling points and melting points. So ionic compounds have very high boiling points and very high melting points. Now comes the answer of the very first question from which we have started, right? That why a very simple chemical compound like NaCl is having so high boiling point and so high melting point. Like its melting point is 800 degrees centigrade, while boiling point was like roughly around 1400 degrees centigrade. So why is this so? And I have told you that we would discover this answer when we would study chemical bonding, and here we are. Okay, so the reason behind the high melting and boiling point of the ionic compounds is very simple. We have already studied it, that when these ionic compounds are formed, what happens? There develops a strong electrostatic force of attraction between these ions, right? Yes. And this thing, okay, because of this strong electrostatic force of attraction, what is happening? When we are trying to convert the state, okay, of a particular ionic compound, like suppose I have taken NaCl, okay, so if it is in solid state, so the particles are like very much closely held to each other, right, in this way. Okay, but now when I have to convert it from solid state to liquid state, we know that we have studied matter, right, and we know that in liquid state, the particular substance, the constituent particles of that particular compound or particular substance are like slightly away from each other, okay, as compared to the solid state. In solid state, they are very closely held to each other. So here, when the constituent particles, okay, now here the constituent particles are, we have studied it, ions, right, Na plus ions, Cl minus ions. Now they have to be separated. So what we have to do to separate these particles, to make these particles move away from each other, we have to weaken the force of attraction, right? The strong electrostatic force of attraction which is there between the ions, we have to weaken it. And for weakening this force of attraction, what we have to do? We have to supply energy, right? We have to heat it. So when we are heating, now it depends upon the force of attraction, how much energy would be required. Now here the force of attraction is very strong. It is strong electrostatic force of attraction. It is very strong. So high energy, a large amount of energy is required. Okay. Now what does this mean? We have to heat it till higher temperatures. Okay. And like in NaCl, in the case of NaCl, we have to heat it till 800 degrees centigrade. Then what happens? Our solid NaCl gets converted into liquid NaCl. And the temperature, we know the temperature at which this NaCl gets converted from solid to liquid state, that temperature is the melting point of NaCl, right? Now since it is very high temperature, yes, we got the answer. Why it is very high? See, the melting point is very much high, okay, because of the strong electrostatic force of attraction between the ions. And in the same way, when we are converting it from liquid NaCl to gaseous NaCl, the particles now should be farther away from each other, more far away from each other as compared to the liquid state, right? Now what we have to do again, we have to again weaken the force of attraction from the liquid state. Whatever the force of attraction is there, we have to again weaken it. So again we have to give large amount of energy, right? Which means we have to heat it at higher temperatures. And when the temperature is reaching this temperature 1460 degrees Celsius, roughly around 1460 degrees Celsius, then our liquid NaCl is getting converted into the gaseous NaCl, right? So we know that this temperature, okay, at which the liquid NaCl will get converted into the gaseous NaCl is the boiling point of NaCl, simply. And yes, this is very, very high because of strong electrostatic force of attraction between ions. So friends, next property is dissociation, okay? Now actually you know the meaning of dissociation. It means separation, okay? Now in aqueous solution, okay, and in molten state, okay, of ionic compounds, ions separate, okay, ions dissociate, okay. Now what does this mean, or why is this happening? Let's see, okay. So in aqueous solution, first let's understand what is aqueous solution. Aqueous solution means I have taken an ionic compound, okay, like NaCl, and I have added it into the water, okay. So after adding the NaCl in water, what would happen? Aqueous solution will be formed, okay. And molten state, we already know, if I convert the NaCl from solid state to liquid state, so liquid state is called as molten state, okay. Now in this molten state and in this aqueous solution, what is happening? Ions are dissociating, ions are getting separated. This means that Na plus and Cl minus ions are getting separated, okay. Now in this case, both these cases, now this means that they are now free to move, okay. You have to remember this thing. If they are separated, then they are free to move. They are not now bonded to each other very strongly. And why is this happening? Because the very reason I told you right now, they are not bonded to each other very strongly right now. The strong electrostatic force of attraction, okay, which was between the ions, okay, it has been weakened, okay, in molten and aqueous state. Now since it is being weakened, so the ions are like somewhat free to move, okay. The ions become mobile, the ions can move. Now why the strong electrostatic force of attraction is weakened? See, when we are converting from solid to liquid state, just now we have seen that we are providing a large amount of energy, right, in order to weaken the electrostatic force of attraction, strong electrostatic force of attraction. So because of this supply of large amount of energy, the strong electrostatic force of attraction weakens and ions get separated, ions dissociate. And in case of water or in case of aqueous solution, what is happening? Water is also doing the actually same thing which the heat energy is doing, okay. Water is also weakening the strong electrostatic force of attraction between this Na plus and Cl minus ion. Since the strong electrostatic force of attraction is weakened, so these Na plus and Cl minus ions are dissociated, they are separated, and now they are free, somewhat free, mobile to move, okay, in solution and in the liquid state. Now let's connect this, or let's relate this with electrolysis. Now don't worry about electrolysis, we are going to study it in very much detail in a chapter, okay. It is a complete chapter, but for right now let's just have a crisp idea, okay, how we can relate the dissociation with electrolysis. So what is happening? See, in electrolysis, simply you just remember in this way, there are two rods which are inserted, okay, in our aqueous or molten NaCl, okay. So here there is aqueous or molten NaCl, okay, and in this aqueous or molten NaCl, these two rods are dipped, and these two rods are connected to a battery, and they are also connected to a bulb, okay. Now what is happening? I have switched on the battery, so it is the positive terminal, and current has been started. Okay, current has been started to flow from the positive terminal, and it has reached this rod. Now when I start the battery, I find that, oh, the bulb is glowing. So this means that the current is flowing from this positive terminal to the rod, and then something is happening and the current is being conducted to this rod, and again the current is being flowing through this wire, and then the bulb is glowing. So this means that something is happening here and there is a conduction of electricity. And who is conducting this electricity? This aqueous or molten NaCl is conducting the electricity. Now how it is conducting? Here comes our dissociation. So just now we saw that Na plus and Cl minus ions are separated in aqueous and molten state, right? So this separated Na plus and Cl minus ions, what they are doing, they are free to move, right? They are mobile. So they migrate to the respective electrodes. Now here this rod is called as an anode, okay, and this rod is also called as an electrode. This rod is also called as an electrode, and this is a cathode. Okay, don't worry about the specifications or details. So what is happening? The positively charged species, okay, is moving towards the cathode, okay, and negatively charged species is moving towards the anode. So these ions are, in short, you remember right now is these ions are migrating towards the respective electrodes. And what is happening? The electrical contact or electrical contact is being established, right? And the electricity is being conducted by this aqueous or molten NaCl. Okay, in this way we have related the dissociation with the electrolysis part. So the next property is conductivity. Okay, so first is heat. So do ionic compounds conduct heat? Yes, very well, they are good conductors of heat. But now moving to the case of electricity, there is a twist in the story. Okay, these ionic compounds are good conductors of electricity when they are in the molten and aqueous state, but they are poor conductors when they are in the solid state. Now why is this so? Just now we have related it, right? We just now have seen the electrolysis in which our aqueous and molten state NaCl was conducting electricity, right? Now we also know the reason why it was conducting electricity. Okay, so let's first start with why the solid state, why the ionic compounds in solid state don't conduct electricity. Okay, so strong electrostatic force of attraction is present between the ions in solid state, so the ions are not able to move, right? There are no free ions now, and if there are no free ions, how they can migrate to the respective electrodes? They can't migrate, so they can't conduct electricity. Now it's clear. But now just now we saw that in aqueous and molten state, what is happening? Ions are dissociating, ions are getting separated. So ions are getting separated, so they are like free to move, they are mobile, and that is the very reason the ions migrate towards the respective electrodes and conduct electricity. Now why was this happening? Why the ions are free to move, or why ions are dissociating in molten state or aqueous state? Because the force of attraction between the ions is weak in molten and aqueous state, right? So this also we have seen, and why it has been weakened, we know the reason very well, okay, in both the cases. Now the last property of ionic compound is solubility in water. Now I think I don't need to tell you this thing, you already know, because you would have definitely tried dissolving your normal common salt, okay, NaCl, in water, and you would have found that yes, it is getting dissolved. So yes, ionic compounds are soluble in water. Now why is this so? Okay, we are going to see it in very much detail when we would study water, okay, as I have told you before as well, in covalent bonding. Okay, but for right now what you can understand is water is a polar compound. Okay, this also we are going to understand it in very much detail. What are the polar compounds, what are non-polar compounds? Now since water is a polar compound, what it is doing, it is actually, suppose I am taking this ionic compound NaCl, so it is actually weakening the strong electrostatic force of attraction between these Na plus and Cl minus ions. So what would happen? We have already seen this thing, the ions dissociate, right? The ions get separated, now they are free to move, now they are mobile in this aqueous solution, and that's when we say that, oh, our salt has dissolved. Okay, now it's time to see some questions. So draw the electron dot diagram for the compounds given below. Represent the electrons by dot and cross in the diagram. they have given the atomic numbers of calcium, oxygen, chlorine, sodium, magnesium to us. And now which compounds they have given? For which compounds we have to draw the electron dot diagram? First is calcium oxide. Now this was asked in your 2020 examination. Okay, I have just summarized. Okay, I have just clubbed the questions for ease. Okay, then second, they have asked the electron dot structure of sodium chloride in 2019 in your ICSE examinations. And third one is magnesium chloride. They have asked this in 2017. Okay, in your examinations. So all the three compounds electron dot structure we have already studied, right? We have already learned. I have told you how to draw the structures, and this is the favorite question, I guess, of the examiners, because these questions are like the electron dot structures they frequently ask in the examinations, okay, of different ionic compounds as well as covalent compounds. So what you have to do is you have to be thorough with this. And how you would be thorough? They know that if you know how to draw, or if you can correctly draw the electron dot structure, you know the process of formation of that compound. Okay, so that's why I have told you to just remember or just understand how the ionic compounds are formed, and then you would be easily able to draw the electron dot structure without making any mistake. Okay, next is give a reason. Ionic compounds have a high melting point. Okay, so this was asked in your examination 2018. We have already seen the reason as well. Okay, we know that they have high melting points, and the reason as well, right? Because of the strong electrostatic force of attraction between the ions. Okay, so this is the key word. If you would miss any of the word, then your marks would be. And yes, so why we have to write the why? Give a reason, they have said. Okay, so it is 1 mark question, so we have to write the why in very concise way. We don't have to explain it in the whole manner. Okay, so in concise way we can just write it in a one statement, that because they are having strong electrostatic force of attraction between the ions, due to which what we have to do is we have to supply large amount of energy to weaken this force of attraction. Okay, so since we are now it's understood that since large amount of energy is supplied, so the compound is heated at high temperature, and therefore it is having high melting point. Okay, now next is fill up the blanks with the correct choice given in the brackets. Ionic or electrovalent compounds do not conduct electricity in their dash state. Okay, so they have given us the two states, fused and solid. Okay, so fused here means molten state or liquid state. Okay, so we have studied this, that in solid state they don't conduct electricity. Okay, they are asking us the ionic compounds do not conduct electricity. Okay, in their which state? So we know in fused state or in molten state and in aqueous state they conduct electricity, but in solid state they don't conduct electricity. And why? We have already seen it. Okay, so the answer here is solid state. They do not conduct electricity in the solid state. Okay, then state the type of bonding in the following molecule. Calcium oxide. So this is asked in your 2017. The previous question was asked in 2018. Okay, in your examinations. So this kind of simple questions also are asked. Okay, so state the type of bonding in the following molecule. Calcium oxide, we already know, we have studied it's all the Ramayana and Mahabharata. So calcium oxide is having ionic bonding, right? So friends, with this we have reached the end of this video, and we have learned all the concepts of ionic bonding in this video. So I hope you would have enjoyed learning with me, you would have understood all the concepts, but please do let me know in the comment section whether you have enjoyed or you have understood all the concepts or not. And as you all know, learno matlab free hai par best hai. So stay tuned. We will see the remaining concepts of this chapter in the next video. Till then, bye bye and have a great day.